So a projectile is fired at 12.5 meters per second at 53.1 degrees with the horizontal 75 meters above the ground. We're going to find the time it takes to hit the ground, max height, horizontal distance that the projectile traveled, and the velocity it hits the ground. So first thing I'm going to do is I'm going to draw a picture. And he's projectiling it just by throwing it. And it's going to be 12.5 meters per second, 53.1 degrees. And so here's our triangle. He's 75 meters above the ground. So here's the ground. So givens, we have 12.5 meters per second would be our velocity initial. 53.1 degrees is our theta. And negative 75 meters is our y, because that's the distance it's going to travel downward, the displacement, I should say, not distance, but the displacement, because it'll start here and down here for the y direction. Our unknown, it's wanting us to solve for time. Also, not only does it wants us to solve for time, but if you look at all the equations, the only equation that will have all those variables will be the y equals vi sine theta t plus 1/2 at squared. Notice we have t here and t there. You do not want to do this equation. Okay, whenever solving for time, do not use this equation. The only time you can use it is if vi is 0, because that will cancel this out. So do not use this equation. Instead, we're going to have to solve for something else, something that we don't know. And so we could actually just solve for the velocity final in the y direction, and then that'll help us solve for time. So first thing I'm going to do is solve for VFY. So the equation I will use for VFY squared equals vi squared sine theta squared plus 2ay. We have all of those, so we're just going to take the square root of both sides. We'll have VFY equals radical vi squared sine theta squared plus 2ay. From there, we're just going to plug in. So we have VFY equals, we have 12.5 meters per second squared sine 53.1 degrees squared plus 2 negative 9.81 meters per second squared times negative 75 meters. The acceleration we got, well, it's because it's in the y direction, so the acceleration is always going to be gravity. So that's how we got that. So for VFY, it should be negative, because when it hits the ground, it's going to be going downward. VFY, we will get .35 meters per second. For our y value. Okay, now we have that y value. Now we can just solve for time. For time, we can now use the equation VYF equals VI sine theta plus AT. Solving for time. So we're going to do PEMDAS backwards. We'll subtract VI sine theta, divide by A. So we'll have VYF minus VI sine theta, divided by A equals T. From there, we'll plug in negative 40.35 meters per second minus 12.5 meters per second sine 53.1 degrees divided by negative 9.81 meters per second squared. And that will give us our time. You should get 5.13 seconds. And that'll be our time.